So the next thing to start with our inspection is going to be our cylinders. We've measured our piston, we've determined that the piston is still within usable dimensions. Now we want to see if the barrels or cylinders are in usable shape. So I've got two cylinders here, still working with the 911E. First one is gonna just show you some wear in the actual cylinder. This is from the one that had the piston damage where the skirt scored against the cylinder wall. So we can see these long scores up and down in the cylinder. And this cylinder itself is not usable as it is. The only way it would be usable would be to use an oversized piston. Our next cylinder that we're going to inspect has normal wear. We can see this line down here in the bore. This is where the piston actually stops. It does not protrude past this, and you can almost still see the cross hatching in the cast iron liner just below it. Now this line here is a stain. It actually has no feelable profile to it. And so even though it looks bad, it would come out with a hone. But what I want to do is I just want to rotate everything around, and I'm looking for obvious signs of damage or heavy scoring. The other part where it's going to wear is going to be right at the top here. When the piston comes up and stops and the rod actually moves over center and it starts to go back down, this is typically right here in this area where you will get the most amount of wear. Now, if it was really heavy wear, we'd be able to feel something with our fingernail or our finger. So far, this cylinder does not have any excessive visible wear, but we're going to go ahead and measure it next. So I've got our specification sheet here. We have verified on our cylinder that the specification is 0. So what I'm going to do is I'm going to take my standard marking at 0. I'm going to look at my cylinder diameter new, should be 84 millimeters to 84.01 millimeters. I've gone ahead and set up my bore gauge, and I have calibrated it to 84.00 millimeters. So what I need to do is I need to take my measurements at D1 and D2 in the cylinder. This is going to give me the taper. So typically when a cylinder wears, it will wear more at the top than it will at the bottom. This D1 measurement is typically taken at around 30 millimeters below the deck height. And then D2 is going to be taken with parallel to the gasket surface or the copper shim surface inside the barrel. So that's going to be the usable range. So what I'm going to do is I'm just going to bring my gauge in, and I'm going to rock my gauge back and forth until I get the smallest measurement. So right now I am reading 84.032 millimeters at the top. So I'm just going to go ahead and write that number down as D1 is 84.032 millimeters. Then I'm going to move my gauge down to the gasket area and rerun that measurement. And looks like the smallest number I have here is 84.024. So D2 is 84.024. The other thing that I want to do is measure for ovality. So I want to make sure that the cylinder is still round. So what I'm going to do is I'm just going to rotate my cylinder by 90 degrees. And I'm going to retake my measurements at the same locations and see what changes I have. So on D2 we have 84.026. And if I bring it back up to D1, we have 84.028. So now that we have our measurements, we can go through and compare them to our specifications. So the cylinder is worn out when the dimension is 0.1 of a millimeter over its original size. The largest measurement we had was 0.032. So the dimensional size of the cylinders are still in usable condition. The next measuring dimension is going to be on ovality. So the ovality should not be more than 0.04 of a millimeter. To get that number, we are going to take the two measurements that we took on D1. We have 84.032 minus 84.028, which equals 0.004. So the cylinder for ovality is still within usable dimensions. The next measurement that we want to look at is going to be our piston to bore clearance. So on our piston, it said it needed 0.05 as its minimum clearance. Porsche specifications for discard is 0.15 of a millimeter bore clearance. So if we take our maximum bore size of 84.032 minus 84.032 minus 83.93, we have a current piston to bore clearance of 0.102. Now that says that we are within spec, but we are halfway through our available wear limit. The next thing that we have to consider is the cylinder will need to be honed. So once we hone the cylinder to remove any glazing or marking so the new rings can seal, this number may increase. And this is one of the considerations that we need to think about before we continue to decide whether to invest more time in honing the cylinders, being that it could open up the clearance closer to our wear limit and we would have to discard anyways, or installing it with it so close to the wear limit that the life of the engine is going to be considerably shorter. Another quick way to measure a piston to bore clearance is I've got my piston installed with no rings, I've cleaned the piston and I've cleaned the cylinder bore. I'm just going to take the maximum clearance, which is 0.015 of a millimeter, which is anything above that number is considered discard. And if I can slide that in like I can on this, then our clearance is going to exceed the maximum usable clearance for the piston and cylinder arrangement. So when we have spiral cylinders or cast iron cylinders, these have a lot of options for wear. Our one cylinder here is showing that it is within tolerance right now, though may go to an oversize or outside of tolerance after it's honed. If that is the case, then these cylinders can be overbored to a next size up. So that would go from typically 84 millimeters to an 85 millimeter piston, in which case we would order a custom forged piston to go into it. Porsche says that if the tolerances are outside of specifications, to replace the entire piston and cylinder itself. That is also an option, though it can get very expensive. Porsche will also let you replace only one cylinder. So if the rest of the engine is in good shape and one cylinder had a problem, like our cast iron cylinder here where a piston caught the side of the liner, you could replace just this piston just so long as you match this height group rating. All of the height groups need to be the same on the same bank in the engine. Theoretically, you could have cylinders 1 through 3 being one height group and cylinders 4 through 6 being a different height group, though I wouldn't recommend it, just for simplicity's sake. On Nicocil cylinders, and these are aluminum cylinders that you can tell immediately by the difference in weight. Even though this piston is a 90 millimeter piston, so it's 6 millimeters larger than the spiral cylinder, the weight is approximately a half of what the spiral cylinders are. Now, some unique things with Nicocil is the lining that is put on the aluminum sleeve. There is no cast iron liner in these. If we take a look at this one that has suffered a lot of damage, we can actually see where the coating has started to flake off of the actual liner itself. This one suffered a lot of damage. I can also see on the sealing surface here, this is where the CE ring would sit. This one had a head stud failure where the head studs were not retorqued. One stud came out of the actual engine. The rest of them, the nuts were loose, and this barrel was vibrating in the engine up against the cylinder head. So you can see all of the damage that's happened here. This barrel is not savable in any way, shape, or form. You can also see on the cooling fins, because the barrel was moving up and down, the actual air guide plates have started to eat into the cooling fins. On a barrel that is just worn, like this one, we can see inside the surface is not too bad. There is no major damage. The sealing surface is in reasonable shape to where it hasn't been fully cleaned yet, but it hasn't been vibrating. These can be sent out and re-Nicociled, so the plating redone on the inside of the cylinder, and a custom piston built to match. Generally though, I would be looking at replacing an entire set with the amount of damage that was on this cylinder and its other corresponding cylinders in the engine.